guys, so this time around, we're going to discuss the work on a spring. Okay? So, basahin muna natin yung discussion part. So, let me just get my highlighter. So, work of a spring force. If an elastic spring is elongated on a distance ds as shown in the figure 14-5a. So, ito siya. Ayan. So, ito yung elongation niya. So, then the work done by the force that acts on the attached particle is du is equals to negative Fs ds, from where yung Fs mo, or the force produced by the spring, is equals to negative K multiplied by S. Ano ba yung K natin dito? So guys, yung K is the spring constant. Okay, so that is in a unit of force over distance. So to get the force, i-multiply mo lang siya ng distance, S. Ayan. Okay? So, the work is negative since F sub S acts in the opposite sense to ds. So, magne-negative siya if opposite yung direction niya dun sa ating ds. So, kung mapapansin nyo dito, yung ds mo kasi is papunta siya dito sa right, and yung F sub S mo is papunta dito sa kaliwa. So, di ba kapag ina-elongate natin yan, yung spring, ang tendency kasi niyan is bumalik sa original position niya. Kaya yung F sub S mo is papunta sa kaliwa. Okay? So, because of this elongation, yun nga, humaba. So, meron siya kasi siyang potential energy, or because of that pulling force, meron siyang contradicting force na compressive, or again, ang tendency niya is to go back to its original shape. Okay, so if the particle displaces from S1 to S2, the work of Fs is then U sub 1 is to 2 is equals to the integral of Fs ds, from where the limits is S1 up to S2. Ayan, so nung ginawa niya ng diagram kung saan yung F sub S is in the y direction and yung S is yung X. Ito. Okay, so the equation will be equals to, again, just substitute yung negative Ks dun sa F sub S natin, ds. So our equation is negative 1/2 of Ks sub 2 squared minus 1/2 of Ks sub 1 squared. So this work represents the trapezoidal area under the line F sub S is equals to Ks under the figure 14-5b. Ito. So, trapezoidal daw yung shape niya. Okay, so, ayan, kinuha lang naman yung area nito. So, the work, gets yun na naman siguro to kung ba't naging ito. So, h over 2. Ayan, so ito yung h over 2. So, S2 minus S1. Ito po. And then, yung area lang nito. Ano? So, at this point, this is KS2. Ayan, and then at this point, itong height nito, this is KS1. Ayan, so kaya nabuo natin yung equation na to. So, naka-simplified form na lang siya. So, this work represents the trapezoidal area under the line Fs equals to Ks. So, a mistake in sign can be avoided when applying this equation if one simply notes the direction of the spring force acting on the particle and compares it with the sense of direction of displacement of the particle. So, if both are, ito, mahalaga to. So, if both are in the same sense, positive work result. So, kung pareho sila ng direction, ayan, so positive work yung maproproduce natin. And if they are opposite to one another, then the work is negative. So, mas mauunawaan nyo to kapag nag-solve tayo ng mga example. So, isinama ko na rin ito. Ito naman is na-discuss na rin sa unang part. So, in the procedure for analysis, so the work of a spring is of the form U sub S is equals to 1/2 of Ks squared. So ito lang din yun, guys. Ano? So where K again is the spring stiffness or spring constant, and S is the stretch or compression of the spring. So it's either elongation yan or shortening. Ano? So kapag nag-length yung ano mo or na-stretch, so again, ang tendency niyan, so coming from this position, originally, ayan, so kapag in-elongate mo yan, ano, So, yung force ng spring mo is katulad nito. Ano? And kapag shortening naman, so coming from this original diagram, kapag ganyan naman, so syempre ang tendency niya naman is bumalik dito sa kanyang original shape. Okay? So, and so para mas maunawaan, try natin mag-solve ng mga problems regarding work for a spring. Okay, so for problem number 6, so basahin muna ulit natin. So a block which is 3,000 Newton in weight slides down and inclined, having the slope of 3 vertical, ito, and 4 horizontal. So it starts from rest, and after moving 1.2 meter, so ibig sabihin, yung distance na to is 1.2 meter. So sabi dyan, it strikes a spring whose modulus is 1,500 Newton per meter. So yung modulus na yan, yung K natin, which is the spring, yung isa pang tawag is spring constant. So if the coefficient of kinetic friction is 0.2, so may friction pa nga pala tayo dito sa surface, find the maximum velocity of the block. Okay? So initially, let's draw first the free body diagram for this block. So again, gawa lang po ako dito ng X and Y axis, which is parallel along dun sa inclined plane natin. So this will be my X, and this will be my Y axis. So what are the forces acting on this block? So first, we have here the weight of the block, which is equals to 3,000 Newton. So if this is 3, therefore, ito is 3, and then ito is 4. Okay? And then since may friction yan, and we all know na kapag may friction, we need to solve first for the value of its normal force. And since the block is going in this direction, initially, pababa, and states there that it starts from rest, therefore the initial velocity of that will be equals to 0 meter per second. So therefore, the frictional force will be going in this direction. Okay? So, other than that, wala namang ibang force na nag-a-apply dyan. So, kapag nag-apply tayo ng SRB or when we take equilibrium equation, so to solve for N, so assuming in this direction as positive, take summation of forces Y equals to 0. Therefore, N is just equals to 3,000 multiplied by 4 over 5. So that is equals lang sa, saan yung calcu ko? Ito. So 3,000 times 4 divided by 5. So that will be 2,400. Ayan. So therefore, the frictional force is just equals to mu, kung saan yung mu is 0.2 times 2,400. Or that will be equals to 480. Ayan. So that is 480 Newton. Okay, so second condition natin na kailangan i-consider dito. Guys, because of this weight, ang sabi nga, itong weight na to nag-slides down across dito sa inclined surface na yan. Therefore, syempre, pagdating niya dito sa point na to, naka-gather na yan ng speed eh. And because of that speed, ang tendency ng spring mo is mag-shorten. Okay? Or magkaaroon siya ng deformation. Or kapag inanalyze mo siya, ito. So, let's just say that this is our IP. Initial position. And then final position. And so, para mas ma-visualize lang. Okay? Gawa lang natin dito. Ayan. So guys, yung spring nyo, kung ganito siya kahaba before, anong nangyari dyan? Na-compress na yan. Ayan. So medyo exage lang ulit natin yung drawing. Okay, so again, initially, alam natin na yung spring mo is nandito. Ano? So ito guys, ito yung S or yung distance na diniform or yung ikinompress or isinorten ng spring mo. Okay? So, kailangan muna nating masolve yan para malaman natin yung maximum velocity ng block. Okay? So, what will happen in this equation? So, sige. With that, so magsasummation tayo ng work. Okay? So, from point 1 up to point 2. Or yung block mo is nandito na. Consider na natin yung work done by the spring. So again, that is just equals lang sa summation ng work. Patang ko lang yung kulay nito. So that is summation ng work, or that is equals lang sa positive work minus negative work is equals to 1/2 of the mass times the final velocity or yung velocity niya sa final position niya. So, gawin ko na lang b sub 2 squared minus b sub 1 squared. Okay, so ano ba yung mga analysis na kailangan natin gawin dito? Guys, pagdating ng block mo kasi dito, ano ba pwede maging kulay nito? So, syempre, yung block mo, sasandal na siya dyan. So, the question here is, ano yung magiging velocity ng block natin pagdating niya sa point na to? So, again, initially, ganito siya. Then, nag-shorten, ayan siya. So, nung na-reach na yung point na yan, so what will be the final velocity of the block here? So, imagine nyo lang. Imagine nyo, yung spring. So, initially, nandito yung block mo, and then, nung nirelease mo siya, ayan, tumama siya dito, and then, ang nangyari nga, because of this block, nagkaroon ka ng shortening do sa spring. And then, once it reaches this point, so what will be the final velocity of your block here? Okay. So, tama. So, that will be also equal to 0 meter per second. Ano? So, with that, ang mangyayari sa part ng equation na to, kung parehong 0 pala to, therefore, I can cancel out this part of the equation. So, ang kailangan ko na lang malaman is yung difference between the positive work and the negative work. So, before we proceed with that one, so, ano ba yung mga forces na makakapatulong para magkaroon ng positive work? So, syempre, you need to consider the x component of this force. Tama? Kasi, ayun nga. To solve that is just equals to 3,000 times 3 over 5. Okay? So, 3,000 times 3 over 5 and then multiply. So guys, ang i-consider na nating distance dito is ito lang ha. Okay? So yung 1.2 lang, hindi na natin a-addan siya ng S. Ano? Kasi yung S na yan, i-consider mo lang siya para do sa part ng spring. Okay? Ayan. So, aside from the x component of the weight, I think wala nang ibang force na nakatulong para magkaroon ng positive work. So, the remaining forces are for the negative work. So, yung isang negative work mo is the frictional force, which is equals to 480 times the distance na 1.2. So, just like the x component of the weight, so, yung distance na i-consider mo lang is 1.2. Ano? Hindi mo na a-adda ng plus S. So, again, yung S mo is for the spring only. And then, minus. So, bakit minus? So, because of this, ayan nga, yung na-compress mo kasi yung spring mo, ang tendency kasi ng, tawag dito, ng force do sa spring mo, ayan, yung F sub S mo na yan, is itulak. Ano? Kumbaga, itulak pabalik, kagaya ng direction ng iyong frictional force, opposing siya doon sa direction ng distance na trinable niya or yung diniform ng iyong spring. So, minus, again, anong ba yung equation natin? 1/2 of K From where yung K nga is the spring constant na 1,500 times x. So yung x mo, or yung dinisplace ng yung spring na s, which is the unknown, and then squared. So equals to 0. So with that, mahanap natin yung value ng s mo, which is equals lang sa, so pindutin lang natin sa ALQ. Mag-transpose ko na lang sa kabila to, this part of the equation, lipat ko dito sa side na to. So 3,000 times 3 divided by 5 times 1.2, and then minus 480 times 1.2. Okay, so multiply lang natin ng 2, and then divide natin ng 1,500, and then square root of the answer. So the answer for that is 1.45. Medyo malaki pala, no? So napaliit pala yung drawing ko. 1.4533 meters. Okay. So hindi pa tayo tapos, ha. Next, ang magiging point of analysis naman natin to get the value of the velocity is on this point. Okay, so the point where the block will reach its maximum velocity. So again, ito na yung consider nating figure. So ang gawin na lang natin, medyo i-drawing na lang natin siya ng panibago. Or gamitin na lang din siguro natin to. So if you're going to analyze that, again, at this point, yung velocity mo kasi will be equals to 0. So again, what will happen is, due to this Fs, ang tendency niya ulit is itulak or bumalik sa original shape. So mangyayari dito, babalik siya ulit pataas eh. So mangyayari, tutulak niya. And yung velocity na tinutukoy dito is yung velocity niya pagdating niya ulit dito sa original position niya or dito sa point na to. So ang mangyayari, ito yung magiging initial position natin, and then ito will be our final position. Okay? So knowing that at the initial position, dapat nga pala drawing natin ng panibago. Anyway, disregard niya itong velocity na to. So ang gawin ko na lang, ano pa bang kulay hindi nagagamit? Green. Okay. So again, this will be our initial position for our analysis 2 or second analysis natin. Ngayon naman, ang mangyayari, yung compressed condition niya, ang mangyayari, babalik natin siya dun sa original shape ng spring. So this will be our final position. So again, nung pagkatulak niya dito, so di ba ito yung originally, ito yung block mo. Ayan. So, ang mangyayari, ano ba? Ibang kulay, itim na lang, itim. Ayan. So, nung pagkarating niya ng block dito, ayan. So, nag-attain na siya ng velocity eh. So, yung final velocity dito, yan yung hinahanap dito sa problem. Bakit hindi ko considered pabalik ulit sa original position niya? Since it is inclined upward, we all know na yung velocity mo, yung final velocity dito sa position na to, is less than compared sa value na makukuha natin dito. Kasi pataas nga yan eh. Diba, kapag inclined upward, ang tendency niyan, unti-unti ulit siyang babagal. So, the maximum velocity will be attained once na yung spring mo and yung block is nando sa original position ng spring. Or nangyari, eto na yung block natin. Since tumulak na nga yung spring mo or nagkaroon ng pushing force, so syempre yung block dito is nag-gain na ng speed. So yan yung maximum speed na pwede niya ma-attain dyan sa scenario na yan. Okay, so yun yung maganda explanation na doon. So paano ba natin siya makukuha? So since spring na lang yung pinag-uusapan natin dito, again, yung friction mo at saka yung weight ng block, hindi na natin siya i-consider. Okay? So ang mangyayari dito, ganun ulit, summation ng work, positive work minus negative work is equals to 1/2 of the mass times the velocity squared. Since itong force na to and yung S na yan is going in the same direction na, ang mangyayari dito, positive na yung value ng iyong work done by the spring. Kasi ito, papunta doon, and then yung S mo is papunta na rin sa kanan. Okay? Pareho na silang going to the right or papunta sa taas. So, 1/2 of K. So, again, ang K mo, where is K? K. Ito, 1,500. Then, multiply by X, which is yung S, yun na-compute natin kanina, 1.4533 squared. So, equals to 1/2 of the mass ng block na 3,000. So, divided by 9.81. Then, multiply by the final velocity. Itong velocity dito. So, BF squared minus the initial velocity, which is equals to 0. So, direct na lang natin dito So, 0 squared. Ayan. So, what will be the final velocity of the block? The maximum velocity daw. Tignan natin yung calculus. So, ano to? Answer. So, squared answer times 1,500. And then divided by 2. Dapat kinancel ko na lang. Okay lang. So, times 2 ulit. Times 9.81. And then divided by 3,000. And then square root of the answer. So, the answer for that is 3.2186 meter per second. Alright, guys. So, that is our final answer. Okay, so I'll give you 3 minutes to copy the solution. So you may start copying. Sige, habang nakakopya. So, ang isa ko pa kasing iniisip dito, pwede kasing na-attain niya yung velocity niya the moment before siya lumapat dito sa spring. Or yung saktuhan lang. Kung saan may velocity pa rin siya. So, dito kasi, in-assume na yung maximum velocity is natin nung pumulak siya. So, what if, ano kaya yung velocity niya nung moment na tumama lang siya dito? O yung lumapat lang? So, I hope nagigets ako doon sa anong yun. So, analysis na yun. Pwede kasing ang mangyari, baka nandito yung, maximum velocity niya. Okay? So, mangyayari lang dito sa part na to, ng equation na to, is, ito hindi natin isasama yung sa spring. Kasi walang work na nag-conduct sa spring. Kasi ito lang yung ina-analyze natin. So, ang gagawin ko, habang nakakopya kayo, ito lang yung consider natin, di ba? Yung positive work tsaka negative work due to the friction. So, copy ko lang to. So, 3,000 times 3 over 5 is 1.2. Check lang natin maaari kasing ito pa nga rin yung maximum. So, if less than yung mauha natin dito, so, wala dun ang maximum velocity. So, sa gumawa ng problem na to, maaaring inisip niya na yung force na ng spring, yun yung makapag-produce ng maximum velocity. Pero possible kasi na habang gumagalaw siya pababa, na-attain na niya yung maximum velocity niya. Pero check natin if hindi ba naka-apekto masyado yung sa frictional force. So again, wala siyang spring kasi ang ina-analyze natin is from this point up to this point. Wala pang shortening na nangyari sa spring. In the moment na lumapat pa lang siya. So 1/2 of the mass kita pa ba sa OBS to? Kita pa. So final velocity, BF squared na lang to So ito, considering before tumama doon sa spring. So before spring. Ayan. Or gawin natin ito. Ito yung before spring. Check lang natin. Di ba mas sinabi na nandun nga? Naisip ko lang. 3,000 times 3 divided by 5 times 1.2 times 2 pareho lang sila ng velocity. So, pwede rin to. So, kahit pala hindi ka na mag-ano sa spring. Ano? So, this can be considered as your alternative solution. Pero may spring kasi. So, ayun. Kaya ang ginawa natin, kinonsider natin yung spring. Pero pareho lang pala sila ng velocity, no? Na maating lumapat siya dun. Ayan, so kopyahin nyo na lang din to. Okay guys, so let's proceed with the next problem. Okay, so for problem number 7. So this is a CE board 2003 November. So basahin natin. The 3 kilogram slider. So ito yung slider mo. And then yung weight niyan or yung mass nitong itong point na to. Saan ba yung ballpen ko? So ito yung tinutukan niyan 3 kilogram. Ayan. So the 3 kilogram slider is released from rest at point A and slides with a negligible friction in a vertical plane along the circular rod. Okay, so circular to, medyo ano lang kasi mano-mano yung drawing. So that touch spring has a stiffness of 350 Newton per meter and has an outstretched length of 0.75 meter. Okay, so dito, masasabi na natin na ito ay merong force produced by the spring since yung original unstretched length niya is 0.75. So, kung i-analyze mo kasi ito, that is doubled na or 1.5 meters na yan. Ibig sabihin may naka-stored na yung force or energy. Okay, so for letter A, which of the following gives the gravitational potential energy if the slider passes position B? So, mangyayari, pagpunta niya daw dito sa point B, ano daw yung gravitational potential energy niya. And then for letter B, which of the following gives the elastic potential energy if the slider passes position B? And letter C, which of the following gives the velocity of slider as it passes position B? Okay guys, so siguro magtataka kayo, sir, ba't nagkaroon ng mga potential energy dyan? Okay, so yung variation kasi ng nung equation natin, di ba, sabi ko nga, summation ng work is equals to positive work minus negative work is equals to 1/2 of mass velocity squared, 1/2 of mv squared. Okay, so this is final minus initial. From where itong part na to is kinetic energy. So guys, dito sa part na to, yan yung potential energy. Okay? So, ang mangyayari lang dito, so kung maalala nyo dun sa ating previous video, di ba sabi ko, yung isang variation ng formula nito is PE1, peke-peke, is equals to KE sub 1, is equals to PE2, PE sub 2, plus KE sub 2. Okay, so ano ba yung mga potential energy natin? So, isa dyan, isang potential energy na pwedeng natin i-consider is yung gravitational potential energy. So, merong potential na mag-release siya ng energy. And then, ganun rin yung si spring, di ba? So, meron din siyang potential energy. So, ang tawag naman sa kanya dun is, eto, yung elastic potential energy. And, yun din naman yan. So, nangyari nga lang dito, so, PE1 minus PE2. So, kung isipin mo rin kasi, ganun din eh. So, ito is somehow, kapareho lang din ito. So, for this type of problem, ng mga ganyan, papadaanin mo sa rod yung spring, alamin mo kung ano yung mga force or yung velocity dito sa point na to. So, etong formula na to yung gamitin nyo. So, pwede rin naman to. Pero, again, ganoon din kasi, doon ka rin mag-a-arrive sa equation na to. Okay? So, which of the following gives the potential energy if the slider passes position B? So, ang tinatanong lang dyan, guys, is yung gravitational potential energy pagdating niya doon sa point 2. So, mangyayari dyan is potential energy at point 2 minus potential energy at point 1 due to the gravity. So, if you're going to set this as your reference point, or ito yung reference line, okay? So, yung potential energy do sa point 1, again, this is point 1, and then ito, yung point B mo, yung magiging point 2. Okay? So, kung point 1 yan, ibig sabihin, pantay sila eh. So, therefore, this part of the equation is equals to 0. So, yung potential energy due to the gravity, mgh yan. So, siguro familiar na kayo sa equation na to, since na naman sa physics yan. Ayan. And then, i-consider mo dyan yung magnitude niya. So, since pababa yan, so therefore, that is negative. So, what will happen here is mass na 3 times 9.81 and then times negative 0.75. Okay? So, what will be the answer here? So, pindutin na natin sa calculator. So, 3 times 9.81 times negative 0.75. So, that is negative 22. Negative 22.0725. So, that is in joules or Newton meter. Okay? So, joules na lang natin. So, this is the answer na hinatanong for letter A. Next, for letter B, para naman dun sa elastic potential energy if the slider passes position B. So, para naman dun sa elastic potential energy or yung EPE. So, ito naman guys yung para sa spring. Yung 1/2 kx squared. Yung position to niya minus 1/2 of k tapos x sub 1 squared. So, ganun din guys. Kung nasa baba siya, so yung x natin is negative. So, 1/2 of k. So, yung k. Ayun, 350. And then, x. Ito pala yung length nga. Again, So, initially, ito nga, yung haba ng spring niya dito is equals to 1.5. Ngayon, nung dumating siya dito sa point na to, Ayan. So, what will be the length of the spring here? So, para makuha yung distance na yan, so, ano ba yung form natin dito? Di ba triangle? Or that is equals lang sa square root of 0.75 squared plus 0.75 squared. Or that is 1.0607. 1.0607. And yung x na tinutukoy nga ulit dito, o yung s, pwedeng x or s, so that is the difference between the stretched length minus the unstretched length. Or, ang mangyayari dito guys, di ba, ito, ang haba niya nga dito is 1.5. So, paano nga ulit nakuha yung 1.5? So, that is just the sum of these two, 0.75 plus 0.75. So, that is 1.5 minus yung original length niya, which is 0.75 squared. And then, minus 1/2 of k na 350 ulit times the stretch length na 1.06. Baligtad. Baligtad. Final position minus initial position nga pala. So, ito dapat yung 1.06 ha. Ito guys ha, 1.0607 minus 0.75. So, final minus initial nga pala yun. And then ito, so ito yung dapat na 1.5 minus the initial. So, 1.5 squared minus 0.75 squared. Nagkakamali na naman. Dito yung squared. Kx squared. Ayan. So, what will be the elastic potential energy? So, pinutin lang natin. So, 2 inverse times 350 times 1.0607 minus 0.75 squared minus 1/2 of 350 times 1.5 minus 0.75 squared. Okay, so that is negative 81.54 ano yun? 39. So 5440. 5440. So again, the unit is in joules or Newton meter. So this is the answer for letter B. Okay? And last, which of the following gives the velocity of the slider as it passes position B? So, paano naman makukuha yung sa position B na yan na velocity? So, again, ito lang ang gagamitin natin. Or, that will be, if you're going to consider the answer we computed for letter A. So, again, ito lang siya. PE plus KE at 0.1 minus PE2 minus KE2. So, ang nangyari kasi dito, PE2 minus, so, transpose siya dito. So, yung kinetic energy, yung wala. Paano nga natin ito i-simplify? So, at point C, so, para mahabol natin yung form na ito, ang nangyari kasi dito, ito yung mga nilipat. Ano? So, ito transpose natin sa kabila, yung kinetic energy. So, magma-minus. So, nangyari, negative KE2 plus KE1. Ayan. So, KE2 plus KE1 is equals to PE2 so para mahabol natin yung form na 1/2 kx squared. MB squared na nga pala to kasi potential. So, multiply ko ng negative 1. Ano? So, para mangyari, maging positive to, tapos ito maging negative. Or mahabol natin nga yung form na ganito. Ayan. Ano? So, in short, ito magiging negative. So, 1/2 of the mass na 3. So, final velocity niya dito, ito. So, yung velocity at point B squared. Minus yung initial velocity. From where yung initial velocity niya, again, at point A, so sabi naman dyan, so rest, so meaning ito is equals to 0. So equals to yung mga nakuha natin kanina, yung GPE at saka ano. So negative 22.0725 minus 81.5440, hagip pa ng OBS. Hagip pa naman. So negative, negative, negative. So what we can do here is multiply mo ng negative 1 both sides. So maging positive na siya. So ayan, may makukuha na tayong velocity dito at point B. So just take the sum of the GPE and EPE. So that will be, times ko lang ng negative 1 to. So plus 22.0725 and then times 2 and then divided by 3 and then square root of the answer. So the velocity there is 8.3113 meter per second. Ayan. So that is the answer for letter C. So huwag malilito dito ha. Again, i-rearrange ko lang yan. Kaya naging ganito. Kasi nga ito, coming from this, ayan, transpose ko lang dito sa kabila yung PE. Kasi nangyari nga dito, di ba? PE2 minus PE1. Tapos yung potential energy dun sa spring, anong nangyari? PE2 minus PE1 din. Ngayon, ililipat ko sa kabila yung kinetic energy. Kasi ito, naging minus nga, or negative. Ang kailangan kong form is ganito. Ang naka-negative is yung KE1, o the kinetic energy at position 1. So, para mangyari yun, in-multiply ko ng negative 1. Kaya nangyari, ang sagot kanina dito is negative yung una. Okay? So, again, please copy. I'll give you 3 minutes to copy. And then after this, discussion na lang ng power. Kung TV lang. Power. At saka efficiency. Okay? So, yung mga problems, kayong bahala na dun. Pero hindi na ako magbibigay sa exam. Ito na lang. Didiscuss ko na lang. Since yun naman ituturo sa inyo sa hydraulics, kung di ako nagkakamali. Hydraulics nga yun. Efficiency of pump. Tsaka yung power. O power rating. Okay guys, so let's proceed with the next discussion regarding power and efficiency. Okay, so the term power, ayan. So this provides a useful basis for choosing the type of motor. Okay? So pag nagdi-design ka, especially ng pump, mga water tank, so ayan yung isa sa kailangan mo i-consider. Yung power rating, kung paano mo ba madadala yung tubig on a higher elevation. So, power or machine which is required to do a certain amount of work in a given time. So, for example, two pumps ayan na nga, may each be able to empty a reservoir if given enough time. However, the pump having the larger power will complete the job sooner. So, the higher the power, the higher the job output ng kaya niyang gawin. Pero higher if energy, lang din. Demand. Yung proportional naman yan. So, the power generated by a machine or engine that performs an amount of work du within the time interval dt is therefore, so power is equals to du all over dt. From where yung u mo nga, so that is expressed as force times distance. Okay? So again, ang unit niyan is Newton meter, pound feet, etc. And then yung time is in seconds. So ito nga. So P is equals to du over dt. Again, du is equals lang daw sa F times the distance. So dito, ang nilagay niya lang distance is dr over dt. So F multiplied by dr over dt. So alam naman natin na distance over time. So ito ay equal sa velocity. Okay? So kung ibababa mo yan, ayan. So ano na natin dito. So the formula, one formula for power is equals to force times velocity. Pero ito, pwede rin siya na ano nga yun? Yung work, yung force times distance over time. So, if given ito, so ayun lang, W over T lang siya. And then kung given is force at velocity, so ito yung equation ng power. So ito, sa uloy nyo na lang. So ganun, kailangan mo lang naman mahabol na unit dito minsan kasi kahit di ko sa uloy yung solution, basta alam mo yung unit ng power. Di ba yan ay watts, mga horsepower. Alam naman natin na yan ay equal sa force, ano ko na lang dito, force times distance over time. Ayan. So, minsan kahit unit lang, hindi mo sa ulo yung equation or yung formula, mapapalabas mo yung power. Hence, power is a scalar where in this formulation, V represents the velocity of the particle which is acted upon by the force F. Ayan. So, V represents the velocity and F represents the force. The basic unit of power used in the SI and FPS systems are the watts. Ayan. So, ang watts again, extension niya, or kapag in-expand mo is joules per second. Horsepower. So, again, may mga conversion naman yan. And these units are defined. So, again, 1 watts, ito pala, nilagay dito, is 1 joules per second. And yung joules, alam natin na yan ay equals to Newton meter. And isa pang mahalagang conversion niya is yung HP to pound feet or foot pound na 550 yung conversion niya. I think this is, meron nitong conversion sa alky nyo. Pa-check na lang ako. And kapag horsepower to watts, so ito, siguro alam kong familiar kayo dito sa figure na to. 746 watts in 1 horsepower. Ito, this is for the efficiency, guys. So the formula for efficiency, the mechanical efficiency of a machine, is defined as the ratio of the output of useful power produced by the machine to the input of power supplied to the machine. So output over input. Okay, so yun na lang tandaan. Hence, if energy supplied to the machine occurs during the same time interval at which it is drawn, then the efficiency may also be expressed in terms of the ratio energy output over energy input. So, ito isang mahalaga pa rin. Since machine consists of a series of moving particle, frictional forces will always be developed within the machine. So, kaya nga guys, naglalagay ng mga lubricant. So, especially kasi doon sa may mga parts na may gear. Para kasi yung efficiency mo is tumaas. Kasi yung friction na yan, syempre, yan yung nagkakos kasi para bumaba yung efficiency ng isang bagay. Ang habol kasi natin as much as possible, yung output na ma-produce mo is equals lang do sa input. O yung makukuha mong value is 1 or 100%. Yun yung admirable na value or ratio ng output sa input. Pero kapag mga 90% pataas, ayan, okay, medyo okay na yan. Kasi hindi naman talaga maiiwasan na because of yun nga, yung mga friction na ganyan. Nagkakos kasi yan para bumaba yung efficiency mo. So that's why, especially sa mga sasakyan, so regular maintenance yan. Kasi ang habol nga natin is efficiency. Tapos kung sobrang tanda na ng mga machine mo, so that's the reason why kailangan mo na siyang paltan or a upgrade. Yan, ganyan. So since machine consists of series of moving parts, frictional force, ito nga, always be developed within the machine. And as a result, extra energy or power is needed to overcome these forces. So consequently, power output will be less than power input. And so the efficiency of a machine is always less than 1. So the power supplied to a body can be determined using the following procedure. So this is the procedure for analysis. So first, determine the external force F acting on a body which causes the motion. This force is usually developed by a machine or engine placed either within or external to the body. If the body is accelerating, it may be necessary to draw its free body diagram and apply the equation of motion, where summation of forces equals to mass times the acceleration. So to determine the F. So once you have the F and the velocity v of the particle where F is applied have been found, the power is determined by multiplying the force magnitude with the component of velocity acting in the direction of F. So again, that is power is equal to force times the velocity. So in some problems, the power may be found by calculating the work done by F per unit time, where P average is equals to delta U over delta T. Okay, so that ends the discussion for the work and energy. So siguro guys, mag-provide na lang ako sa LMS natin. Maglagay na lang ako doon ng mga sample problems for the power and efficiency. Pero sabi ko nga sa inyo, kapareho lang din naman siya ng concept doon sa hydraulics na yan. Okay? So that ends the video lecture for this topic, Module 7, under work and energy. So next topic natin, next and last topic will be the impulse and momentum. So guys, see you on our next video lecture. Goodbye.